Speed of calculating powers in Python. I'm curious as to why it's so much faster to multiply than to take powers in Python, though from what I've read this may well be true in many other languages too. For example, it's much faster to do than. I suppose the operator is more general and can also deal with fractional powers. But if that's why it's so much slower, why doesn't it perform a check for an int exponent and then just do the multiplication? Edit. Here's some example code I tried. Now POW2 is just a quick example and is clearly not optimized. But even so, I find that using n equals 2 and r equals 1 million, then POW1 takes 2500 milliseconds, and POW2 takes 1700 milliseconds. I admit that for large values of n, then POW1 does get much quicker than POW2. But that's not too surprising.
Basically, naive multiplication is O(n) with a very low constant factor. Taking the power is O log n, with a higher constant factor. There are special cases that need to be tested. Fractional exponents, negative exponents, etc. Edit. Just to be clear, that's O(n) where n is the exponent. Of course, the naive approach will be faster for small n. You're only really implementing a small subset of exponential math, so your constant factor is negligible.
Adding a check is an expense, too. Do you always want that check there? A compiled language could make the check for a constant exponent to see if it's a relatively small integer because there's no runtime cost, just a compile time cost. An interpreted language might not make that check. It's up to the particular implementation unless that kind of detail is specified by the language. Python doesn't know what distribution of exponents you're going to feed it. If it's going to be 99% non-integer values, do you want the code to check for an integer every time, making runtime even slower?
Doing this in the exponent check will slow down the cases where it isn't a simple power of 2 very slightly, so isn't necessarily a win. However, in cases where the exponent is known in advance, e.g. literal 2 is used, the bytecode generated could be optimized with a simple peephole optimization. Presumably this simply hasn't been considered worth doing. It's a fairly specific case. Here's a quick proof of concept that does such an optimization, usable as a decorator. Note, you'll need the byteplay module to run it. Which gives the timings. Edit. Actually, thinking about it a bit more, there's a very good reason why this optimization isn't done. There's no guarantee that someone won't create a user-defined class that overrides the _mul_ and _pow_ methods and do something different for each. The only way to do it safely is if you can guarantee that the object on the top of the stack is one that has the same result x2 and xx, but working that out is much harder. Egg. In my example, it's impossible, as any object could be passed to the square function.
An implementation of b to the power of p with binary exponentiation.
Python tutorial, please consider subscribing.